Hi there, Miss Barber here. This lesson is called the substitution rule. Many of the integral formulas are based on corresponding derivative formulas. Here, we will learn a process of integration often called method of substitution. This procedure is based on the chain rule for differentiation. This is a very useful technique and is indispensable in calculus 2. Explore. Use the chain rule to find the derivatives of the following functions. Part A. f of x equals the quantity 5x to the fourth plus 3 raised to 6. Using the chain rule, you would say f prime of x is equal to 6 because we bring the power down, and then the quantity 5x to the fourth plus 3 all raised to 5 because it's 1 power less times the derivative of the inside function. The derivative of 5x to the fourth is 20x cubed. The derivative of 3 is 0. Let's simplify by multiplying 6 with the 20x cubed, so our derivative will be f prime of x equals 120x cubed times the quantity 5x to the fourth plus 3, all raised to 5. Part B. G of x equals the negative of 2 divided by 3 times x cubed plus 8 raised to the power of 3. We will use properties of exponents to rewrite this. Let's write it as negative 2/3 and x cubed plus 8 to the power of negative 3. Now we'll use the chain rule again. G prime of x is equal to, the negative 2/3 is a constant, so it just comes along for the right. Derivative, we bring the power to the front. So you have negative 3. The quantity x cubed plus 8 stays the same, and you subtract 1 from the existing power. So negative 3 minus 1 is negative 4. Remember, it's the chain rule, so we must take the derivative of the inside function. The inside function is x cubed plus 8. The derivative of x cubed is 3x squared. The derivative of 8 is 0. Let's combine some like terms. First, I would reorder it and write it as negative 2/3 times negative 3 times 3x squared, and then the quantity expression x cubed plus 8 to the minus 4. Let's multiply the numbers together, and that's 6x squared times the quantity x cubed plus 8 to the minus 4. Let's go ahead and rewrite that negative exponent. So g prime of x is equal to 6x squared divided by the quantity x cubed plus 8, all raised to the power of 4. Let's continue with a refresher on the chain rule. H of x equals sine to the fourth x divided by 4. Let's rewrite this in a more differentiation-friendly form. So we'll move the 1/4 out to the front and make it the coefficient, and sine to the fourth x is the same thing as sine of x to the power of 4. We'll use the chain rule. H prime of x is equal to 1/4, that's the constant, it stays put. Now we have sine x to the fourth. The derivative of the outside function, we bring the 4 and make it a coefficient. So you got 4, the sine x stays put, raised to the power of 4 minus 1 is 3. Remember to multiply by the derivative of the inside function. Sine x is the inside function. Its derivative is cosine x. Let's do the arithmetic. That's multiply the 1/4 with the fourth, and we'll get f prime of x is equal to sine cubed x cosine x. Continuing with the exploration, refer to the derivatives of the previous exercise for the integrals of the following functions. Part A. Integrate 120x cubed times the quantity 5x to the fourth plus 3, all raised to 5 dx. The question that needs to be answered is the derivative of what function will give us this 120x cubed times 5x to the fourth plus 3 to the power of 5 dx. We know that it's 5x to the fourth plus 3 to the power of 6. Don't forget the plus c. If you were to differentiate that as we previously did, the derivative would give us what we need to integrate. Part B. Integrate 6x squared divided by the quantity x cubed plus 8 raised to the power of 4 dx. The task here is to find a function such that when you take the derivative of that function, it will give 6x squared divided by the quantity x cubed plus 8 to the power of 4. The antiderivative is the negative of 2 divided by 3 times the quantity x cubed plus 8 to the power of 3 plus c. Part C. Integrate sine cubed x cosine x dx. To find this integral, we need to have the function such that when you take the derivative of that function, you get sine cubed x cosine x dx. We know what that is. That is sine to the fourth x over 4 plus c. In the Explore exercises, had we not first taken the derivatives using the chain rule, we would have been hard-pressed to come up with the integrals. Integration by method of substitution equips us to find antiderivatives of such functions. The rule states, if u equals g of x is a differentiable function whose range is on interval I and f is continuous on I, then the integral of the composite function f of g of x times g prime of x dx is equal to the integral of f of u du. Notice we have composite function here. Explore some more. Now use the substitution rule to find the integrals of the following functions. We're going to do this by method of substitution. First thing I would suggest is we reorder our integrand. Write it as the integral of 5x to the fourth plus 3 to the fifth times 120x cubed dx. Multiplication is commutative. We can change the order. Now, we are working with a composite function, so we need to assign an inside composite function variable. I'm going to let u be 5x to the fourth plus 3. That's our inside function. Let's take the derivative of u. Then du would be 20x cubed dx. Wanting to make a substitution, we have an issue because we have a 120x cubed dx and du is 20x cubed dx. Let's multiply by 6 on both sides. Then 6 du would be equal to 120x cubed dx. Now we can make direct substitutions. That is, we get the integral of, and instead of 5x to the fourth plus 3, we replace it with u to the fifth. And where we had 120x cubed dx, well, that in terms of u is 6 du. Let's apply some properties of integration and move the 6 to the outside of the integral symbol. So that'll be 6 times the integral of u to the fifth du. That's pretty straightforward to integrate. Using the power rule for integration, you have the constant 6 times, and then 1/6 u to the 6th. Don't forget the plus c. 6 times 1/6, that becomes 1, and substitute back. So where u was, put in 5x to the fourth plus 3, and the integral is 5x to the fourth plus 3, all raised to the power of 6 plus c, just like we previously obtained. Part B, Integrate 6x squared divided by the quantity x cubed plus 8 to the power of 4 dx. We'll practice the method of substitution here. First thing I would do is rewrite that integral to read the integral of 1 divided by the quantity x cubed plus 8 to the 4th times 6x squared dx. We need to construct our composite function. The inside function is x cubed plus 8, so I'm going to let u equal x cubed plus 8. Then the derivative of u, that would be du, would be 3x squared dx. In our integral, we have a 6x squared dx. We need the 3x squared dx to be 6, so we'll multiply by 2 on both sides. 2 du is equal to 6x squared dx. Now we can make a direct substitution. Where the x cubed plus 8 was, we'll put in u. And let's go ahead and write that as u to the minus 4 using rules of exponents. And where 6x squared dx was, we'll replace it with 2 du. Using properties of integrals, we'll move the constant 2 to the outside of the integral symbol. And you have 2 times the integral of x to the 4th du. Using the power rule for integration, that is, you add 1 to the power and 1 divided by that same number, you'll have 2 times u to the negative 1/3, because you're adding 1, then you have 1 divided by negative 3 plus c. Let's replace the u back with x cubed plus 8, and our result will be the negative 2 in the numerator, 3 in the denominator, putting in x cubed plus 8 where u was, raised to the 3, plus c. Note, that's what we needed. Find the integral of x cubed x cosine x dx by method of substitution. I begin by rewriting our integrand as the integral of sine x in parentheses raised to the power of 3 times cosine x dx. The inside function, that's what's in the parentheses, is sine x, so I'll let u equal sine x. Then we need to take the derivative on both sides. Du, the derivative of sine x is cosine x dx. We can make a direct substitution, so the integral of sine x cubed cosine x dx is just the integral of u cubed du. Use the power rule for integration. That integral is 1/4 u to the 4th plus c, and then replace the u with sine x, which will give us the desired 1/4 sine to the 4th x plus c, just as it needed to be.